Hello student, chapter 2 MCQ number 15. Range of the fx is equal to sin inverse x plus tan inverse x plus sec inverse x is dash. So here first of all, domain of sin inverse is -1 to 1. Domain of tan inverse is R, and domain of sec inverse is R minus -1 to 1. So now here three domains are obtained. Now if we take the intersection of all these terms, therefore domain of f is equal to -1 to 1 intersection of R intersection of R minus -1 to 1. So is equal to only and only -1 and 1. Therefore f from -1 to 1 to R is the required function. Now we want to find the range. Therefore, we put -1 and 1 in the given function. So we have f minus 1. It is sin inverse -1, tan inverse -1 plus sec inverse -1. Sin inverse -1 is minus pi by 2. This is minus pi by 4 and plus pi minus sec inverse 1. So sec inverse 1 is only pi and 0. Pi minus 0, or it is 0. So ultimate our answer is pi by 4, right? And f1 is equal to sin inverse 1 plus tan inverse 1 plus sec inverse 1. It is pi by 2 plus pi by 4 plus 0, or it is 3 pi by 4. Therefore, range of f is equal to pi by 4 and 3 pi by 4. Only two elements can be obtained here, and this is the range of the given function. Okay, now we go for the next one. So here, if sigma I equal to 1 to 10, cos inverse xi is equal to 10 pi, then sigma I equal to 1 to 10, xi is equal to dash. So here first of all, what we can do here, 0 is lesser equal to cos inverse xi, or cos inverse xi is lesser equal to pi. Therefore, sigma I equal to 1 to 10, cos inverse xi is equal to cos inverse x1 plus cos inverse x2 up to cos inverse x10, which is 10 pi. Now for the 10 terms, answer is 10 pi. Therefore we can say that for each cos inverse xi, the value of this cos inverse xi is pi. Therefore I equal to 1, 2, 3 up to 10. And then the value of xi is -1 for every I is equal to 1, 2, 3 up to 10. Now sigma I is equal to 1 to 10, xi is equal to what? x1 plus x2 plus x3 plus x4 up to x10. So we just put the value of them, which is -1, -1, -1 10 times. It is -10. So the value of the sigma I equal to 1 to 10 xi is equal to -10, right? Okay, so this sum is quite different from the other sum, so be careful for this type of sum. Now we go for the next one, and you remember all the formulas of the chapter 2. Okay, Next sum, this value of sine inverse 2x root 1 minus x square equal to dash, where the condition is very important that x belongs to minus 1 to 1 upon root 2. So here first of all, what we do here, we just assume that x equal to sine theta, right? Therefore, sine inverse 2 sine inverse 2x root 1 minus x square is equal to sine inverse 2 sine theta into cos theta. It is sine inverse sine 2 theta. This is our first result. Now minus 1 less than x is less than 1 upon root 2. Therefore, we can say that this theta is in between minus pi by 2 less than theta is less than pi by 4, right? Now theta is in between this theta is in between minus pi by 2 to pi by 4. Therefore, we want to obtain 2 theta. So we multiply by 2 minus pi less than 2 theta less than pi by 2. But this 2 theta is not in the interval of sine. So what we do? We just take, therefore we take pi plus theta. This is minus 1. Okay. So here one thing you remember, this is negative. So therefore this is negative and this way. So negative, here the interval is by mistake we take plus 1 upon root 2, but it is minus 1 upon root 2. So now what we have, we just add pi all the side, 0 less than 2 theta plus pi less than pi by 2, right? But now one thing you remember, that sine pi plus 2 theta is minus sine 2 theta. Therefore, sine 2 theta is equal to minus sine pi plus 2 theta put in 1. Therefore, sine inverse sine 2 theta is equal to sine inverse sine minus sine pi plus 2 theta. So this minus we take outside, sine inverse sine pi plus 2 theta, sine are removed, minus pi minus 2 theta, and theta is equal to sine inverse x. So our answer is minus pi minus 2 sine inverse x. So be careful and remember this term, because if your condition is different, then your answer is always different. So be careful for this type of sum, because there are so many sums which are in the base of the given condition, right? So if the condition is different, then your answer is different. Okay, then we go for the next one. So here one thing you remember, that you must obtain this interval is not an interval of sine, okay, because minus pi to minus pi by 2 is there. But when we add the pi, then the interval is 0 to pi by 2, which is the interval of sine inverse, okay, where the sine inverse function is exist. Sine inverse function is exist as at minus pi by 2 to pi by 2. Therefore, we use this relation here and simplify it. Okay, now we go for the next one. Okay, next sum, cot inverse root 1 plus x square minus 1 upon x is equal to dash. Here one thing you remember, that this type of sums are given, then how can you assume the trigonometrical value? So first off, if plus x square is there, put x equal to tan theta. Minus x square is there, put x equal to sin theta. or cos theta, and plus or minus x is there, then x equal to cos theta you must put. If x square minus is given in the beside of the x square, then x equal to sec theta or cosec theta, right? So this way if you assume, then you can easily find out the answer. So here let x equal to tan theta, and theta is belongs to minus pi by 2 to pi by 2, and cot inverse root 1 plus x square minus 1 upon x is equal to cot inverse root 1 plus tan square theta minus 1 upon tan theta. So it is cot inverse pi by 2 means cot 1 plus tan square is sec square, sec theta minus 1 upon tan theta, convert into sin and cos upon sin theta. So cot inverse 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2. 2 cancels, 1 sin is cancelled, tan theta by 2 is there. Cot inverse tan theta by 2, we convert this tan theta by 2 into cot. Cot inverse cot pi by 2 minus theta by 2, cot cancel, pi by 2 minus theta by 2 means 1 by 2 tan inverse x. So this way we can obtain the answer, right? So be careful for this type of sum. Now we go for the next one. Next sum, tan inverse root 1 minus x square upon 1 plus x is equal to dash, where 0 less than x is less than 1. So here first of all we just simplify it, then we can say that here tan inverse root 1 minus x square upon 1 plus x is equal to tan inverse 1 minus x, 1 plus x, and upon root 1 plus x the whole square. So 1 root 1 plus x is cancelled. So we have tan inverse root 1 plus x, 1 minus x upon 1 plus x. Okay. Now let x equal to cos theta, where theta is belongs to 0 to pi. Therefore, tan inverse root 1 minus x upon 1 plus x is equal to tan inverse root 1 minus cos theta upon 1 plus cos theta. It is tan inverse tan theta by 2. Right? Now tan theta by 2 is obtained. Now we want to find now here our condition is 0 less than x less than 1. It means theta is belongs to 0 to pi by 2. Therefore theta by 2 is belongs to 0 to pi by 4, which is included in the interval of tan. Therefore tan inverse root 1 minus x upon 1 plus x is equal to tan inverse mod tan theta by 2, and it is this is greater than, therefore only theta by 2 is there, and 1 by 2 cos inverse x is the answer. Okay. Then we go for the next one. Next sum, 20th, cot inverse root 1 plus x square minus x is equal to dash. So here first of all, here we assume that x equal to tan theta. Therefore cot inverse root 1 plus x square minus x is equal to cot inverse root 1 plus tan square theta minus tan theta. It is cot inverse sec theta minus tan theta upon, not upon, but only this. Now we convert into sin cos. So 1 upon cos, 1 minus sin theta upon cos theta. Now directly we can simplify, but here what we do, here we take at the place of sin theta, we just put cot inverse 1 plus cos pi by 2 plus theta, right? Means pi by 2 plus theta, is equal to minus sin theta, and upon cos theta is sin pi by 2 plus theta. Here one thing you remember that cos pi by 2 plus theta, it is minus sin theta. Therefore we place at the place of minus sin theta, we put cos pi by 2 plus theta. Now we take cot inverse 1 plus cos is 2 cos square angle half upon 2 sin angle half cos angle half. Now 1 cos is removed, so cos upon sin is cot. So cot inverse cot pi by 4 plus theta by 2. Now here this cot is cancelled, and we just put our answer that pi by 4 plus theta by 2. Pi by 4 plus theta by 2. But when you think that, or here theta is in between minus pi by 2 to pi by 2, therefore theta by 2 is in between minus pi by 4 to pi by 4, and theta by 2 plus pi by 4 is in between theta by 2 and pi by 4 is in between 0 to pi. 0 to pi by 2. Therefore we directly put this. Now pi by 4 plus 1 by 2 and theta is equal to cos tan inverse x. So this way we can obtain the answer. Right? Now we go for the next one. Sum. Tan inverse root 1 plus x square plus root 1 minus x square upon root 1 plus x square minus root 1 minus x square is equal to dash, where the condition is given minus 1 less than x is less than 1. X is not equal to 0. So let x square equal to cos theta and tan inverse, we put 1 plus cos theta plus 1 minus cos theta root 1 plus cos theta minus root 1 minus cos theta. Now we know that tan inverse, this is 2 cos square theta by 2, means mod cos theta by 2 plus mod sin theta by 2 upon mod cos theta by 2 minus mod sin theta by 2. But when we take theta by 2 is in between minus 1 to 1 or minus 1 to 1 or 0 is less than theta by 2 is less than pi by 4. Therefore cos theta by 2 is greater than 0 and sin theta by 2 is also greater than 0. Therefore we have tan inverse cos theta by 2 plus sin theta by 2 upon cos theta by 2 minus sin theta by 2. Now we divide it by cos theta, then we get tan inverse 1 plus tan theta by 2 upon 1 minus tan theta by 2, right? So it is tan inverse tan pi by 4 plus theta by 2, right? Now we want to check that pi by 4 plus theta by 2 is in which quadrant. So we know that theta by 2 belongs to 0 to pi by 4. Therefore pi by 4 plus theta by 2 is in between pi by 4 to pi by 2, which is the interval of tan. Therefore tan is cancelled and pi by 4 plus theta by 2 is obtained, which is pi by 4 plus 1 by 2 cos inverse x. So this way we can obtain this answer, right? So it is quite different, and here what you assume and what conditions are given, it is very important. Okay, next sum, sin inverse root x upon 1 plus x is equal to dash, where x is greater or equal to 0. So first of all, we assume that x equal to tan square theta, x equal to tan square theta. Therefore tan theta is equal to root x and theta is equal to tan inverse root x, and where theta is in between 0 to minus pi by 2 to pi by 2, okay, or 0 to pi by 2, because x is greater or equal to 0, so theta belongs to 0 to pi by 2. Okay, now sin inverse root x upon 1 plus x is equal to sin inverse root tan square theta upon 1 plus tan square theta, it is sec square theta. So sin inverse modulus of tan theta upon sec theta, but both are positive, therefore directly we put sin inverse. Tan means sin upon cos, means sin theta is there, and theta is in between 0 to pi by 2, which is the interval of sin. Therefore we put directly theta, which is tan inverse root x, right? So this way we obtain our answer. Okay, then next, okay, 23, cos inverse 1 minus x upon 1 plus x is equal to dash, where x is greater or equal to 0. Here let x equal to tan square theta, where theta belongs to 0 to pi by 2, right? So here cos inverse 1 minus x upon 1 plus x is equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta. It is cos inverse cos 2 theta, right? Now this is our first result. Now if this theta belongs to 0 to pi by 2, means when we multiply by 2 theta, or here theta belongs to 0 to pi by 2, here we take close interval, therefore 2 theta belongs to 0 to pi, which is the interval of cos. So therefore we can say that cos inverse cos 2 theta is equal to 2 theta, and which is 2 tan inverse here root x. 2 tan inverse root x, because here x is tan square theta, therefore tan theta is root x and theta is tan inverse root x, right? So this way we can obtain the answer. Okay, so this way we can do the 23 sum of chapter 2. Now we go for the next in the next lecture. Okay, then